Hey, my name is Carson. I was previously on Team 5203G Gremlin, and with the new release of VEX Override, I've gotten a bunch of questions about this robot we built from High Stakes. A lot of you probably remember it was one of the first robots in the world to high hang. It fell off, it haunted, and got a lot of memes about it. But yeah, it's very complicated, but it has a cool lift system, and some people were asking questions about that for potential use in this year's game. So I thought I'd just make a video to talk about it, kind of explain the thought process behind the design and some of the ways it works. So first of all, I'd like to address what it is. So it's basically a fully string powered elevator lift, maybe cascade lift. I still don't really understand the difference. But yeah, it's an elevator slash cascade esque lift, fully powered by string. So we powered it using a PTO to the drivetrain, and a winch. If you were to recreate something like this, I would still recommend using a winch, just with a dedicated motor probably. Um, but the string went from here, um, at the bottom of the PTO, to this pulley. We had tensioners back here to keep the string very tight, and then it kind of just wraps around in a snake-like shape, which we based off of an FRC video, which you can find pretty easily. For the bottom slide, we have this part here. Um, and this part here that are polycarb parts. There is a lot of plastic on this, but I do know for sure that you could make these slides within the plastic limit based on the new rules. We also use these spacers as rollers. So you can see that we had this all screw jointed. The hex nut locked down there, and then we had a nylock, and then these were also free spinning so that you could have the string run through them. Having free spinning rollers is really important. It helps keep everything really tight. We used half-inch spacers, but you can get away with more custom sizes. But basically, you just want to make sure that there's some good contact, but not too much friction. Then these parts are for the purpose of keeping the slide from going out the side. Um, there are other ways to get around that. You can actually do it by just like using a C channel to bridge everything across, or just more standoffs to bridge everything across, um, and that would work pretty well. But we couldn't do that because the intake was in the way when we were lower down. For the second slide, which this is basically just a main slide, moving slide. You could just repeat this process over and over again until you have the height you want. But yeah, the idea is that anywhere where there is metal on metal contact, you stop that by adding a piece of plexi. That's pretty much the whole idea about it. Um, you can see in here that this C channel contacts this C channel here, so there's a plexi piece in between. Same way with this flat face over here and the flat face in here, so there's a piece of plastic in between. And then that just repeats for this slide, where you can see this contact and this contact. As long as there's a piece of plastic in between, you're pretty good on friction, and you'll have yourself some nice, smooth, pretty well designed linear slides. And all of it gets pretty compact. Um, I think this one came down to about here, and then this one we came down to uh, just around here because we could get away with not lowering that one all the way down. Um, but it did come all the way down to here when we hung, but we kept it about here for when we were intaking. So yeah, I want to address some problems that occurred with these slides. The main one was that each side didn't stay in line. That was the biggest issue with these slides and with the hang in general. To stop that from happening, you would literally just physically screw them together more often. We just couldn't do that because the intake path was straight in the middle of the slide, so we had to leave it very open like this. The other thing is that it might not be rotationally accurate. I'm not the greatest programmer in the world, so it wasn't like we spent a lot of time experimenting with macros. But we did run this rotational sensor on the inside, so you could keep track of how many rotations the winch was going. And if you knew like the speed of your lift, you could definitely get it to a point where it was accurate. We used like Kevlar reinforced string for everything, um, which held up really well. We learned to tie some pretty fancy knots. But yeah, that's all stuff you guys would have to figure out. I think that there's potential for this kind of lift being used in Override. I'm not sure if that's something that I would do or not. So take that with a grain of salt. But I had gotten a lot of questions about it, and so I had the full CAD. I figured I'd just talk about it a little bit. If you have any questions, feel free to leave them in the comment section. I'm also going to link the grab CAD to this robot, or yeah, the grab CAD for this robot step file in the description so that you guys can check it out yourselves and just see how everything works. Um, but yeah, feel free to reach out on Discord or leave a comment if you have any questions. Um, I'm excited to see some really cool lifts this year and some really unique design solutions. It's a pretty cool, complex game. So yeah, good luck in VEX Override, and thanks for watching.